Hello everyone, it's Ms. Zeenat and today we are going to study another new chapter, Heat and Electricity. So what is heat? Heat is a form of energy that keeps us warm or that provides us heat. Okay, both are fine. Now, whenever we are going to use the word heat, we are also going to use something called as thermal. Okay. Imagine you're cooking something. Imagine you're cooking pasta. Okay. You feel that the pasta is done and now you want to remove it. Okay. Are you going to use metal spoon to stir the pasta? Think about it. One scenario is you are going to use metal spoon. Another scenario is you are going to use a wooden spoon. First, are you going to use the metal spoon? No. Are you going to use the wooden spoon? Yes. Why? Because metal is a thermal conductor. Simply, which means that metal is going to allow heat to pass. So do you want to experience all the heat from the pasta in your hand? Do you want to burn yourself? No. So we do not want thermal conductor. Okay. Instead, we are going to use the wooden spoon because wood is a thermal insulator, which means it is not going to allow the heat to pass. So your pasta may be cooking, it may be hot, but when you use a wooden spoon, the heat from the pasta is not going to burn your hands because wood is a thermal insulator, means it will not allow heat to pass. Few more, okay. Now, is metal that bad that we should not use for cooking? No, metal is in fact good. How are we cooking the pasta? Are we cooking it in a plastic bowl? No, because we want the heat to boil the pasta, to boil the water for the pasta. That's why we are using a metal pot, so that we can cook the pasta, because here we need heat. Okay, but do we need the heat in our hands? No. So that time we are going to use the wood because we do not want to allow heat to pass. So examples of thermal conductor: metal, aluminium. Example of thermal insulator: wood, plastic, and air. How air? If you have seen a bubble wrap, the one which you pop it, okay? If you have seen the bubble wrap traps air, and air is an insulator. So that's why it keeps things warm, because heat cannot go outside or heat cannot come inside. It stops both way. That's why we use bubble wrap. We do not use bubble wrap because it's cheap or it's fun to pop. No, we use bubble wrap because it traps air, and air is a thermal insulator. Clear till now? Now, have you seen pizza when it is delivered? It is delivered in cardboard boxes, but there are some grooves. This packaging design helps to trap air, which is a thermal insulator. That's why the pizzas are warm quite longer. Now, similar to thermal, we also have electrical. Same thing, electrical conductor means it allows electricity to pass. It allows electricity to pass. Conductor. Insulator, it does not allow electricity to pass. So example of electrical conductor would be metals like copper. That's why we make wires out of copper. Now, if you do not want to burn your hands, if you do not want to get shock, that would be a better word. If you do not want to get the shock of the current, what you should do? You are going to coat that rubber, coat that copper with a rubber, because rubber is an insulator. So that's why you see the rubber wires coming out of your fan and you do not directly see the copper, because it has been coated to prevent shock. Now we have studied previously circuit. Circuit is the arrangement. So we have lamp, then we have battery, And we have switch. Lamp, I can draw also lamp. Okay. Now this is we can say these are the components of a circuit. Battery, switch, lamp. This is basic. Now what will happen if the switch is open like this? Will the lamp blow? Will the lamp light? No, because we want a closed circuit. So what we will do? We are going to close this switch. If the switch is closed, the light will on. If the switch is open, it will be off because current cannot flow. Current needs a complete path to flow. Now there are two types of circuit which is a part of your syllabus. Simple circuit, we also call it series, or parallel circuit. Series, the bulbs are arranged in a series. Okay. Parallel, the bulbs are arranged parallel to each other. This is the only difference. Now because in series the bulbs are connected in a series, it is not going to be very bright because all these bulbs are going to take the same power and distribute it evenly. That's why series we only use it as Christmas lights for decoration. But parallel is going to take power and it is going to give to everyone equally. It is not going to divide it. It is going to give everyone equally. That's why it is more brighter. That's why all the appliances in our house we use parallel circuits. I hope it is done with this chapter. If you have any doubts, you know where to reach me. Thank you. See you in the next class.